Friends, last we complete exercise 7.2. Now here we discuss about formula of permutation of an object taken R at a time. That is a NPR. Here we know that NPR is equal to n into n minus 1 into n minus 2 up to n minus r plus 1. You know that. Second formula, from this formula, to get n factorial, multiply by n minus r minus 1 up to 1. That is 1, 2, 3 up to n minus r, and divide by 1, 2, 3 up to n minus r. We get here 1, 2, 3 up to n minus r up to n is equal to, we get n factorial upon 1 to n minus r becomes n minus r factorial. So this becomes second formula, NPR. Okay, so NPR is equal to n factorial upon n minus r factorial into r factorial. Here r is arranged object, number of arranged object. So value of r lies between 0 and n. Maybe 0, in between 0 and n, or less than or equal to n. Clear? Now NPN is equal to, remember this, NPN is equal to, using this, n factorial upon n minus n factorial. Here n factorial upon n minus n is equal to, we know that 0 factorial, and 0 factorial is equal to, you know that value 1. So NPN is equal to n factorial. Clear? Next, NP0 is equal to, NP0 equal to n factorial upon n minus 0 factorial is equal to n factorial upon n factorial is equal to 1. So NP0 is equal to becomes 1. Remember this here, NPN is equal to n factorial because here we permute an object in n place. Clear? Up to n place. Here first place can be arranged in a n different way, second can be arranged in a n minus 1 different way, up to last can be arranged in a nth place can be arranged in a 1 different way. So product of all becomes 1, 2, 3 up to n. That is becomes a n factorial. So remember this, NPN is equal to n factorial, and NP0 is equal to 1. That is a 0 object arranged in a n place. For n object are given, then arrange a 0 object and becomes only 1. Remember this. Okay. Now here theorem number 2 here. Number of permutation of n different object taken R at a time, if repetition is allowed. If we have n object and permute R object in R place with repetition, so we have total 1, 2, 3 up to R place. So first object can be filled in a n different way. Repetition is allowed, so all object use for second place, that is we select any one object out of a total n object, and can be happen in a n different way. Similarly third place also can be filled in a using n different object in a n different way. Same last place, rth place also fill in a n different way. So total number of permutation becomes n into n into up to n is equal to n raised to r. Clear this? So if a repetition allow to arrange an object in a R place, then the total number of arrangement becomes, or permutation becomes, n raised to R. Clear? So remember this formula. Now permutation when all the objects are not distinct object. Remember this here. If a given n object, if a p object are like, that is the same type object, and rest are distinct, then number of permutation of n object taken n at a time is equal to, remember this, n factor upon p factor, because p object are like same type. So total number of arrangement becomes n factor upon a p factor. Clear? This is a theorem number third. Here theorem number third given. The number of permutation of an object when p objects are of the same kind and the rest are all different. This is the number of permutation becomes n factor upon p factor. Theorem number 4. If we have total n object and out of n object p1 objects are like, similarly p2 objects are like, up to pk objects are like, and the rest of a same object, then number of permutation is equal to, remember this, n factor upon, here p1 objects are like, so p1 factor, p2 objects are like, so p2 factor. Clear? Up to last of pk factor. So number of permutation of n object in which p1 objects are like, p2 objects are like, pk objects are like is equal to n factor upon a p1 factor into p2 factor up to pk factor. Okay. Like as if we have 1, 1, 2, 3, 4, 4 and 4. 1, 2, 3, 4, 5, 6, 7. 7 object total given, and we want to get, that means a 7 digit. Here we want to form a 7 digit number, then total number of 7 digit number is equal to 7 factor upon, here 1 like a 2 time, so 2 factor, 2 occur 1 time, so 1 factor, 3 occur 1 time, and 4 occur 3 times, so 3 factor. So total number of permutation is equal to 7 factor upon 2 factor into 3 factor. Clear? Now exercise 1.3. First question. Given that how many 3-digit number can be formed using digit 1 to 9. Here to form a 3-digit number using digit 1 to 9 is a one type of permutation of a 9 object taken 3 at a time. So number of three digit number is equal to permutation of 9 digit taken 3 at a time. That means a permutation of a 9 digit 3 times. So is equal to becomes a 9p3. So is equal to 9p3 is equal to, you know that 9 factorial upon 6 factorial is equal to 9 factorial upon 6 factorial. Here 9 factorial is equal to 9 into 8 into 7 into 6. Then write a factorial upon a 6 factorial. Here 6 factorial from both cancel. We get a 9 into 8 into 7 becomes is equal to 504. That is a 504. Clear? Now question number 2. How many 4-digit number are there with no digit repeated? Here we have total 0, 1, 2 up to 9 is equal to 9 digit. Sorry, 10 digit. 0 digit cannot be used for a 4th place to form a 4-digit number. Here in a case of 4th place we cannot use a 0 digit. So 0 digit can't use in a 4th place. Therefore 4th place can be filled using 1 to 9. 1 to 9 is equal to 9 digit in a 9 different way. Clear? Now the remaining 3 digit can be filled using the remaining digit from 1 to 9 and 0, that is total 9 digit we use for this 3 digit or 3 place. Remaining three place can be filled using the remaining 9 digit in a 9p3 way. Therefore total number of a 4-digit number is equal to, here first 4th place can be filled in a 9 different way into remaining 3 can be filled in a 9p3 different way. So is equal to becomes 9 into 9p3 is equal to 9 factorial upon 9 minus 3, that is a 6 factorial, is equal to 9 into 9 into 8 into 7 into 6 factorial upon 6 factorial. Here 6 factorial from both numerator and denominator cancel. We get 9 into 9 into 8 into 7 is equal to becomes total using calculator. Product of 9 into 9 into 8 into 7 is equal to becomes 4536. So 536 becomes total number of 4-digit number. Okay. Now question number third. How many 3-digit even number can be made using digit 1, 2, 3, 4, 6 and 7? 1, 2, 3, 4, 6 and 7. Remember this here. To form a 3-digit even number, first we fill this unit place using even number or even digit 2, 4 and 6. So to form even number, first we fill unit place using even digit 2, 4, 6 and can be happen or can be filled in a 3p1 is equal to 3 factor is equal to 6 way. Now remaining 2 place can be filled using remaining 1, 2, 3, 4 and 5 digit. Now remaining 2 place can be filled using remaining 5 digit 5p3 way. So 5p3 is equal to 5 factor upon 5 minus 3 factor is equal to 5 factor upon 2 factor is equal to 5 into 4 into 3 into 2 factor upon 2 factor. So is equal to here 4, 3, 12, 12, 5, 60. Therefore, total number of 3-digit even number, 3-digit even number is equal to becomes 6 into 60 is equal to 360. Okay. Now question number third. How many 3-digit even number can be made using digit 1, 2, 3, 4, 6, 7? Remember this here. Here we want to form 3-digit even number. For this here, to form even number, unit place can be always filled by using it a even digit 2 or 4 or 6. To form even digit unit place can be filled using digit 2, 4, 6 in a 3p1 is equal to 3 factorial is equal to 6 way. Now remaining 2 place can be filled using remaining here total digit 1, 2, 3, 4, 5, 6 and the one digit already used in a first unit place. So remaining 5 digit we have in our hand to fill remaining 2 place. So remaining 2 place can be filled using remaining 5 digit in a 5p2 is equal to 5 factorial upon 5 minus 2 that is 3 factorial is equal to 5 into 4 into 3 factorial upon 3 factorial is equal to 5 for 20 v. Clear? Therefore total 4 digit even number is equal to 6 into 20 is equal to 120. Clear? Question 4. Find a number of a 4 digit number 1, 2, 3 and 4 digit number that can be formed using digit 1, 2, 3, 4 and 5. If no digit is repeated, how many of these will be even? Here first form a 4 digit number. Repetition is not allowed. No digit is repeated, that is a repetition is not allowed. So total number of a digit is equal to we have 1, 2, 3, 4 and 5 digit and the 5 digit can be filled in a 4th place. So total number of 4 digit number is equal to becomes 5 digit can be arranged in a 4th place, that is a 5p4. So is equal to here 5 factorial upon 5 minus 4 factorial is equal to here becomes 5 factorial upon 5 minus 4 that is 1 factorial, 5 factorial that is 5 into 4 into 3 into 2 into 1. So is equal to 5 into 4 20 into 3 into 2 becomes 120. Okay, so 4 digit number using a given 5 digit is equal to become 120. Now to form a even number, first we fill this place find the number of 4-digit number that can be found using a how many of these will be even. Now to form even number, we fill the first unit place using digit 2 and 4. For even number, unit place can be filled using digit 2, 4 in a 2p1 is equal to 2 factor is equal to 2 way. Now remaining 1, 2, 3, 3 remaining 3 place can be filled using remaining 1, 2, 3 and 4 digit in 4p3 is equal to 4 factor upon 4 minus 3, that is 1 factor, is equal to 4 into 3 into 2 into 1 is equal to 4, 3, 12 to 24 way. Therefore total 4 digit even number is equal to, here unit place can be filled in a 2 way and the remaining 3 place can be filled in a 24 way. So total number of a 4 digit number is equal to becomes 48 and all are even. Okay. Now question number 5. From a committee of 8 persons, in how many ways can we choose a chairman and a vice chairman using one person cannot be hold more than one position? Here for chairman and a vice chairman we have 2 seats for 2 person, chairman and a vice chairman, and the total number of person is equal to 8, and we select from 8 one chairman and one vice chairman, and can be happen in a 8p2 permutation. So number of selection of one chairman, one is a here given chairman, and one is white and second vice chairman. From given total 8 person given, 8 person is equal to number of permutation of 8 person in a 2 place, that is number of selection of a 2% out of a 8%. So 8 factorial upon 8 minus 2 factorial. So is equal to 8 factorial upon 8 minus 2, that is 6 factorial. So is equal to 8 into 7 into 6 factorial upon 6 factorial is equal to 6 factorial cancel. So becomes a 56. Now question number 6. Find and if n minus 1 p3 ratio n p4 is equal to 1 ratio 9. Here given n minus 1 p3 ratio n p4 is equal to 1 ratio 9. Therefore here n minus 1 p3 is equal to n minus 1 factorial upon n minus 1 minus 3 factorial ratio n factorial is np4 is equal to n factorial upon n minus 4 factorial is equal to 1 ratio 9. Therefore simplify this n minus 1 factorial upon n minus 4 factorial into here take a reciprocal of this to change this division into multiplication n minus 4 factorial upon n factorial is equal to here 1 ratio 9, that is 1 upon 9. Clear? Now simplify this. N minus 4 from both cancel. Here we get n minus 1 factorial upon n factorial expand up to n minus 1. So n into n minus 1 factorial is equal to 1 upon 9. Here n minus 1 cancel. We get 1 upon n is equal to 1 upon 9. Therefore n is equal to 9. Clear? Now remaining question we solve in a next lecture. Okay, bye.